There is an inbuilt data set within R which is called as VA deaths. Let me show you this VA deaths. So you have this data. This is the age from 50 to 54, 55 to 59, 60 to 64, 65 to 69, 70 to 74, so on and so forth. You have the rural male, rural female, urban male and urban female. But what are these numbers? In order to know that, we can do a question mark. These are the death rates in Virginia in 1940. Death rates per 1,000 people, basically, right? And the entire explanation is given here. You can read it when you find free time. Now, if I do head of this, it will give you the entire data set. Remember, head function would give you the first 6 entries. And in the data set itself, we have only 5. So all those values are appearing here. Now we have par MF row of 3, 2. So you have 3 rows and 2 columns. Let me run this. Now, if I try to draw the plots, I'm trying to draw a histogram of VA deaths. And when it comes to color, I want heat colors. Heat color would be red and similar to a fire color. And I'm giving a main heading to this, right? I'm mentioning in the bracket that there have to be 7 different colors. So let me run this and try to explain. Oh. Okay, let me erase that and let me rerun that. Let me run everything. Just probably I need to maximize this. Yep, now it's appearing. Okay, if you look at this first one, this row, we want heat colors. Heat colors is similar to your fire, and you're saying that 7 such colors. So first color, second, third, fourth, fifth, sixth, seventh. After 7, the color pattern would get repeated for 8th. If you were at 9th, if you would have had 10th, in that way, right? So this is the beauty of the colors when it comes to R. And you want terrain colors. Terrain colors are mountains, right? Hills, so on and so forth. Desert and all that. So you have green colors, so on and so forth. Since you want 7 colors, after 7 colors, the 8th bar would take the first color. And then you have topo colors, you have cm dot color of 8. When you have 8, it would have 8 different colors because you have 8 bars. Right? If you have 10, there will be 10 different colors, so on and so forth. Rainbow also. So in that way, we can come up with some very interesting colors. Okay, there is another package called R Color Brewer. If you install and load that, this has a few other set of colors available. So if you do MF row of 2, 3, that means you'll be having 2 rows and 3 columns. Let me run that. 1, 2, 3. Because you want only 2 rows and 3 columns. You have 1, 2, 3 columns there. And we have another 3 columns. This color brewer has different set of colors available. If you say you want set 3 colors, it will give you this, some kind of bluish green color, yellow and purple color. And since you told that you want these 3 colors, it would keep repeating the 3 colors. Same is the case with this all. Set 2 colors would have this bluish green color, orange color and purple color, or maybe slightly light blue color, and you have 3, so on and so forth. Same is the case with set 1 also. You have red, blue and green, red, blue and green, so on and so forth. And here you have set 3 of 8 colors. So from set 3 it takes 8 colors, and all these bars, 8 bars have 8 different colors. Gray 8 colors. So this is in black color, increasing order. Green 8 colors, 8 different colors in increasing order in that way. So this color brewer package also has some very fancy colors to be dealt with. So hence R is extremely good at visualization, and this is one of the unique selling propositions of R. All right. I've cleared the console. I've removed all the data sets. I've removed all the plots here. So if you want a plot which is going to represent 3 details, so whenever you do a plot, you'll be able to see X and Y axis. What if you have another parameter? How do you visualize that? We can visualize that using something called as hexagon basically. So here we are trying to plot hexagon of species and sepal length. Let me do that. There we go. So here we are able to see the species and the sepal length, but at the same time you're also able to see the counts. So if you want to look at species 1, probably 5.2 or so length, then it's easy for you to comment that this could be 10 or 11. I would say it is 11. So you have 11 flowers in species 1 which are of length 5.1, right? And this is the same. We have 11 flowers in species 2 which are of the length probably 5.5 maybe. So in that way you can do a lot of analysis. Okay. This is an interesting plot, by the way. And you can do a lot of Xbin, right? There is something called a stable plot. You need to install and load the package called table plot, and then you will be in a position to do the stable plot. Let me run the stable plot. There we go. This is another interesting plot basically. So if you look at this, you have Setosa, versicolor and virginica. These are the 3 species that we have. Do we have any missing data? No, absolutely. We do not have any missing data here. And if you look at the sepal length is steadily decreasing, right? And this is your Setosa. So this part is Setosa basically. From here until here, this chunk is for Setosa. So Setosa has the least sepal length in comparison to the other species. And we also get a sense that versicolor and virginica, it's difficult to segregate those, right? Because those are overlapping to a great extent. And when you look at the sepal width, right? It so happens that your virginica has the lowest sepal width because, you know, from here until here it's all this brown color, and it represents the species virginica. And when it comes to Setosa, which is from here until here, for this part, I just get a sense that the width is highest. So the length is the least for Setosa, and the width, sepal width, is the highest in comparison to the other 2 species. And when it comes to the petal length and width, it is the least in comparison to the other species. And it is very easy for us to differentiate Setosa from the other 2 species, right? So in this way you can analyze the data even using a table plot. And finally, on this IRIS dataset itself, you have a package called VCD, right, which will help you come up with a mosaic curve. So if we do mosaic of Titanic, this one gives you amazing picture. Look at that.